Methods are useful because they contain a sequence of instructions that can be executed at any point in the program repeatedly by invoking the method. And so if you have a sequence of instructions that needs to be executed more than once during the course of a program, probably you want to put those instructions in a method. So that brings us to the DRY principle. The DRY principle stands for don't repeat yourself. Methods are one of the ways to achieve this object-oriented programming principle. A method signature is a method's name along with its parameter types. Circle the method definitions that have a method signature the same as this. So we're looking for a definition that has this same method name and parameters with these types. So taking a look at the first example, we have the right method name and we have the right parameter types. Here we don't have the right method name, so that doesn't qualify. Here we have the right method name, but the order of the arguments is incorrect, so that doesn't fit the signature. Here we have only one of the argument types that is correct. Here we have the two arguments, but we have an extra argument on top of that. So out of these 5 examples, only the first one fits that signature. In this example, we have a class called parcel, and we're instantiating an object of that type here. And then we're invoking the setPostage method on the parcel class. So if we look at the parcel class, we see that there's a setPostage method which takes a double argument and it does a calculation with it, and it stores it in this field. So when I'm browsing code, one of the things I like to do if I need to follow a method and see its definition, you can right click on the method and go to open declaration, or you could just press F3. So if I click F3, that brings me right to the method, which is a pretty handy little shortcut. In this example, I've got a clock class and I'm creating 2 clock objects. They store a time using hours and minutes. And I'm invoking methods called increment minute. And so you can see that we take a number of minutes and we do a little bit of math to move the clock forward a certain number of minutes. Our clock class uses a time class, and inside the time class we store the hour and the minute. What's interesting is that we have what are called instance methods and we have class methods. So you can see that this instance method is being invoked on an object, and this one is being invoked on a class. Eclipse makes this one italic to kind of distinguish the two for you. And in this method, if we take a look at the definition, what it's doing, we can just read the comments. It says that it finds the difference between 2 time objects. Okay, so this doesn't really make sense to put inside the class as an instance method, because which of the 2 clocks should be executing this method? So what I decided is to make it a class method by declaring it static, and that way it's not associated with any particular clock object. Because it's not changing the clock object, that's another reason to possibly make it a class method and make it static. All it's doing is returning a time object that describes the difference between the 2 time zones, for example.